All right, y'all already have all the tools you need to do this whole section. The rest of this section is just extra help, extra examples. Well, let's go. Example 2. We got a factory. They're manufacturing 3 products, A, B, and C. Each product requires the use of 2 machines, machine 1 and machine 2. Wow, this factory are very creative with their naming of machines and their naming of these products. ABC 1 and 2. Wow. The total hours available, respectively, on machine 1 and machine 2 are 180 and 300. Okay, so maybe I add a little total here. 180 for machine 1 and 300 for machine 2. The time requirements and the profit for each product is listed below. So, right, this is the time requirement for each one of these. That's how we can read that table. So product A is going to require 1 unit of time, maybe it's an hour, who knows, 1 unit of time on machine 1, and double that on our second machine. So maybe we're cutting in one and assembling in another, who knows. Okay, this is a very generic problem. All right, so yeah, how many units of each product should be manufactured to maximize profit, and what is that maximum profit? Okay, look at what the question's asking. How many units of each product should be manufactured? Those are our variables. So let's use A, B, and C this time. Let A be the number of product A produced. And then B is going to be the number of product B. And C is going to be the number of product C. All right. And we want to maximize profit. So we're going to say that we want to maximize our profit, which is P. What is our profit? Well, it's going to be 20 for every product A, 30 for every product B, 40 for every product C. We'll add those individual profits together. 20 for every A, plus 30 for every B, plus 40 for every C. That's our profit function. That's our objective function. We're trying to maximize this. Subject to our constraints. What are our constraints? Well, we have a time requirement for machine 1, time requirement for machine 2. Do we only have 2 constraints this time? Let's start with those and then examine that. Okay, so let's start with the time requirement for machine 1. We only have 180 units of time. And machine 1, or product A, is going to take 1 unit of time for every product A created. I'm not going to write the coefficient of 1, but you could. All right, and then product B is going to take 2 units of time on machine 1. Product C is also going to take 2 units of time. And we only have 180 units of time for that machine. So this first inequality, this first constraint, is the time requirement for machine 1. If I had more room, I would probably write that. Now do the same thing for machine 2. Try to find a new inequality. Pause the video right now. Find the inequality for machine 2. It'll be really similar. Right? Product A takes 2 units of time for machine 2. B is also 2 units of time, but C is actually 4 on machine 2. We only have 300 hours available on this machine. All right, so we definitely, I'm going to leave a little space just in case we need it. We're not making negative versions of these, so we're going to say each of these, oh, I need to go ghost again. Each of these has to be greater than or equal to 0. This is shorthand that we can use. Let's go over and make sure we're not missing anything else. Each product requires the use of 2 machines. We've taken care of that. The total hours available on each machine are 180 and 300. We've used that. Time requirements and profit. Well, we use the time requirements for the constraint. We use the profit for the objective function. Yeah, I think that's everything. I think we have a smaller linear program this time. All right, so this is our linear program. Oh, yeah, I was never really good at coloring either. Can't stay in the lines. But this is our linear program right here. Wow. Can't write either. Whoa, I can't write. That was an adventure. Let's solve it. So, can this website handle other variables? Let's find out. I already know the answer, but I'm going to pretend I don't. We're maximizing the profit. What was the profit? 20, 30, and 40. It was 20 for the first, plus 30 for the second, and 40 for each of the third. Subject to the constraints. Also, I'm going to say, hypothetically, what happened if we forgot the formatting? Remember this example button down here will tell you what the things that you're typing should look like. All right. So subject to the constraints, a plus 2b plus 2c less than or equal to 180. (2a, 2b, 4c less than or equal to 300. And A and B and C also have to be non-negative. So again, I'm just going to do a quick check, make sure I typed everything in right. The profits, 20, 30, 40 for each. Good, we got that. First inequality is 1, 2, 2, 180. 1, 2, 2, 180, good. 2, 2, 4, 300. 2, 2, 4, 300. Got A's, B's, and C's next to all that. We got the non-negativities. Let's solve and see what we got. The optimal profit is 3,300. Oh, I'm going to try to be consistent with my colors. Optimal profit is 3,300. A is 0. Oh, rip. B is 30. That's the first time I've ever said rip in a math video. And C is 60. Okay, so that tells us everything we need to know. All right, so the maximum profit is, does it tell us that these are dollars? It doesn't tell us that these are dollars. Is 3,300 monies? You can write dollars if you want. When we produce no product A's, 30 product B's, and 60 product C's. We're going to make sure our answer makes sense. All right, if we do this, just 30 B's and 60 C's, then the machine 1 is going to use 60, 2 times 30, and 120, 2 times 60. 60, 120. Oh, wow, we're using all of machine 1 time. We're using all 180 units. Machine 2 is going to use 60 over here and 240 over here. That's 300. Yeah, we're using all 300. We're not going over. That's good. And then let's see. 30 times 30, that's $900 or something. 40 times 60, that's 2,400. 2,400 plus 900, that's 33. Okay, our answer makes sense. Seems to be consistent with what we'd expect. There we go. That's it. That's the whole video. That's the whole problem. If you want a little bonus, scroll down. Stuff down here talks about tableaus. If you're curious, what is the simplex method? How is it solving it? It solves it in these tableaus, which are kind of like matrices. And then they do a bunch of operations on each tableau to eventually get to the right answer. Anyway, we're not doing that, but that's what's happening on the back end. Let me know if you have any questions, and until the next video, bye-bye.